AI reading minds, huh? It's like something straight out of science fiction, but now it seems like everyone's talking about it.
Yeah, it's definitely grabbed the headlines, that's for sure. And the thing is, it's not just hype, you know? There's some really interesting research happening around AI and this whole theory of mind thing, Tom.
Right, Tom. So today we're going deep on this paper from Harvard that really digs into this whole debate about whether AI and specifically large language models
Hmm.
really have this theory of mind.
Yeah.
The paper is called Re-Evaluating Theory of Mind Evaluation in Large Language Models by Jennifer Hugh, Felix Sosa, and Tomer Ullman.
Yeah, it's a good one. And, one of the first things this paper points out is that even just defining what theory of mind is actually trickier than you might think.
Okay, so before we even get to AI, we need to understand what Tom is.
Exactly. We humans, we just do this mind reading thing naturally, right? We can anticipate what someone else is thinking or feeling, even if they don't come right out and say it. But how we do that is still a bit of a mystery.
So we're like natural mind readers, but we don't really know how we're doing it. That's kind of wild.
It really is. And it makes it, that much harder to figure out if AI is doing something similar.
So where do we even start with this whole question of AI and Tom?
Well, this paper kind of breaks it down into two main approaches. One is what they call behavior matching. And basically, it's looking at whether an AI can produce the same kind of responses that a human would in a situation that, requires theory of mind.
Okay, so if I hide a cookie, can the AI predict that my friend will look for it where they last saw it, even if it's like been moved?
Exactly. That classic Sally Ann test is a good example of this. Sally puts a marble in a basket, leaves the room, and moves the marble to a box. The question is, can the AI correctly predict that Sally will still look in the basket, thinking the marble is still there?
Got it. That makes sense. But you said there were two approaches.
Right. The second one they call computation matching. And this one kind of goes deeper. It's not just about the output, the behavior. It's trying to figure out if the AI is using similar mental processes as humans to arrive at those responses.
Ah, okay. So it's not just about getting the right answer. It's about how you get there.
Yeah, exactly. It's like, think about a calculator that just spits out the right answer for like a multiplication problem because it's basically memorized a giant table of answers
Right.
versus a calculator that actually understands the principles of multiplication.
Okay, that's a good analogy. So just because an AI can pass a classic Tom test, that doesn't necessarily mean it actually has theory of mind.
That's one of the key things that this paper is getting at, yeah. You see, a lot of the claims about AI having Tom, they rely on this behavior matching, right? But critics argue that the underlying computation, like the thinking part, might be missing.
I see. And this is where those LLMs, the large language models, come in, right? Like
Yeah.
everyone's talking about ChatGPT and how it can hold these conversations that seem almost, well, human.
Exactly. And some studies have actually shown that, especially the more advanced LLMs, they can do really well on those classic Tom tests, sometimes even rivaling, the performance of young children.
Wow, that's pretty impressive. But, you're saying there's more to the story.
There is. So it turns out these LLMs can be pretty easily fooled. You just tweak the wording of a Tom scenario a little bit or add a detail that seems irrelevant, in the real world, and suddenly their performance just drops.
Oh, interesting. So they might be good at specific tasks, but their understanding isn't very robust.
Exactly. It's like they've learned to recognize patterns and, produce the expected output, but they don't necessarily have this deep, flexible understanding of mental states.
And that brings us to the whole training away problem, right?
Yeah, exactly. The fact that these closed API LLMs like GPT-4, they're being updated all the time, it makes it really hard to track their true progress on Tom.
Because it could be like learning from their mistakes on the tests.
Precisely. It's like, if you give a student all the answers to the test beforehand, sure, their score is going to go up, but have they actually learned the material?
Right, right. So how can we tell if an LLM is genuinely getting better at Tom or just getting really good at recognizing the specific scenarios that are used in these tests?
Well, the authors of this paper, they argue that to really understand Tom in LLMs, we need to focus on open static models that aren't being constantly tweaked and retrained. That way we can get a clearer picture of what they can actually do.
Makes sense. But earlier you were also talking about how the language itself can introduce biases into these Tom tests. Can you say more about that?
Oh, absolutely. It turns out that the way we translate those real-world scenarios into text for these LLMs, it can actually unintentionally influence their responses.
So how does that work?
Well, imagine a scenario where it says that someone cannot smell the contents of a bag. In the real world, that's probably irrelevant information, right?
Right.
But for an LLM processing text, that detail might make it, overthink things.
Because it's like looking for clues in the text, even if those clues wouldn't matter in a real-world situation.
Exactly. Or say the test scenario uses a word like confusingly. Well, that might prime the LLM to expect errors, which could skew the results.
So the language itself can be kind of a trap.
It can, yeah. And that's why this paper is really pushing for benchmarks that focus on like the core processes of ToM, not just these isolated tasks.
So instead of just testing if an AI can, pass the Sally Ann scenario,
Yeah.
we need to test if it can actually reason about beliefs and actions consistently across, a wider range of situations.
Exactly. And there are actually frameworks being developed to do just that. Two that are mentioned in the paper are Agent and Big Tom. And they're designed to test whether LLMs can, reason about things like goals, actions, beliefs, in all sorts of different situations, not just one specific, pre-programmed scenario.
It sounds like we're starting to get a better grasp on how to evaluate ToM in AI, but there's obviously still a lot to figure out.
Oh, yeah, there's a lot to uncover, definitely. And, one of the most fascinating areas is this connection between ToM and something called pragmatic communication.
Oh, okay. Now, pragmatic communication, that sounds intriguing. What exactly is that? Okay, so we left off talking about this whole pragmatic communication thing. What is that exactly?
So it's basically, the art of reading between the lines. It's that ability we have to understand, like, the implied meaning, picking up on those subtle cues that go beyond just the literal words someone is saying.
Oh, okay. So like when my friend says, "Oh, that's an interesting outfit choice," but their tone is telling me they actually hate it?
Exactly. Or when, someone asks, is there any coffee left? They're not just asking about the physical presence of coffee. What they really mean is they want a cup.
Right, right. So pragmatics is all about like understanding those unspoken social cues and navigating the subtext of conversations. But how does this all relate to AI and theory of mind?
Well, that's where things get really, really interesting because even within cognitive science, there's this debate about how closely pragmatics is actually tied to ToM.
Oh, okay.
Some researchers believe that you actually need ToM to really grasp pragmatic language. Like you have to understand someone else's mental state, their intentions, their beliefs, to actually decipher those hidden meanings.
That makes sense. I mean, to get sarcasm, you need to understand that the speaker doesn't actually believe what they're saying.
Right, exactly. But then other researchers, they argue that pragmatics might be like a separate skill, something you can learn and develop even without being a full-blown mind reader. So like you might be able to recognize patterns in language that signal sarcasm, even if you don't fully, understand the other person's mental state.
Okay, so maybe pragmatics and ToM aren't completely inseparable, but how do LLMs fit into all of this?
Well, LLMs offer a really interesting way to explore this connection. Because, imagine if we can build an LLM that's amazing at pragmatics. It understands irony, it picks up on subtle cues, but it really struggles with those classic ToM tasks. Well, that might suggest that they're not as intertwined as some people believe.
Ah, so LMs could actually help us untangle this whole complex relationship between pragmatics and ToM.
Exactly. And that's why this paper is really encouraging researchers to study this connection more directly. Can we predict an LLM's performance on ToM tasks based on how well it handles, things like irony and metaphors? Are there specific computational mechanisms that like underlie both? Those are some really, really exciting questions that, people are just starting to look into.
This reminds me of something we were talking about earlier, about how the language used in those ToM tests can sometimes trip up LLMs. Is there a connection there with pragmatics?
Oh, that's a great observation. Yeah, it absolutely ties in. Because if an LLM is super sensitive to these subtle linguistic cues, which is essential for pragmatics, those cues could inadvertently influence its performance on a ToM task.
So like a well-placed confusingly in the test scenario could like throw off the LLM's interpretation.
Exactly. And that's why it's so important to design those tests really carefully. We need to be mindful of the fact that, LLMs, especially the newer, more advanced ones, they're trained to be helpful, to be cooperative. They're always trying to anticipate what we want from them.
Which is, great in most situations, but
But it can create challenges when we're trying to evaluate their ToM abilities objectively. An LLM that's really focused on being helpful, it might overattend to certain details or like try to read between the lines in ways that a human just wouldn't.
so the very qualities that make these LLMs impressive, as conversational partners, could actually hinder their performance on these ToM tests.
It's kind of a paradox, yeah. And it highlights the need for, even more sophisticated testing methods.
Okay, so we've talked about these classic ToM tasks like the Sally-Ann test and the limitations of using them to assess true understanding. We talked about the challenges of just relying on behavior matching and the importance of looking at those underlying computational processes. And now we're adding this whole layer of pragmatics on top of it. Is there any way to cut through all this complexity and figure out what's really going on in the minds of these LLMs?
Well, that is the million-dollar question, isn't it? And it's one that researchers are really struggling with. One interesting avenue is to explore whether LLMs exhibit something called Rational Speech Act reasoning, or RSA.
Okay, RSA. Break that down for me.
So RSA basically suggests that when we humans communicate, we're constantly trying to anticipate what the other person is thinking and how they'll interpret our words. We're not just choosing words randomly. We're choosing them based on what we believe will be most effective in, like, conveying our meaning.
So I'm not just speaking, I'm like strategizing, trying to predict how my words will land on the other person.
Exactly. And the listener is doing the same thing, trying to decode our message based on their understanding of our mental state and the context. It's like this constant mental dance, this back and forth of trying to understand each other's intentions.
Like a game of mental chess.
Yeah, that's a great analogy. And some researchers are starting to explore whether LLMs are actually engaging in this kind of RSA-style reasoning.
Right.
They're looking for evidence that, when LLMs generate responses, they're actually taking into account the listener's likely inferences and beliefs.
And if they do find evidence of that, what would it mean?
Well, it would be a pretty big deal. Not only would it offer a computational explanation for how LLMs handle pragmatics, but it could also provide more support for the idea that, LLMs are developing at least some aspects of ToM.
Wow. So exploring pragmatics in LLMs, it could really be a key to unlocking some of the mysteries of both AI and the human mind. But obviously, there's still so much we don't know.
Absolutely, and that's what makes this whole field so exciting. This exploration of ToM and LLMs, it's pushing the boundaries of AI, and it's forcing us to confront these, really fundamental questions about, intelligence, understanding, and the nature of communication itself.
Well, I think our listeners are ready for a break after all that mind-bending discussion. But when we come back, I'm really curious to hear what you think about the future of all this. What are the big open questions, and where do you see this field heading?
Okay, so we're back and ready to, kind of wrap up this deep dive into AI and theory of mind. We've covered a lot of ground here. Those tricky ToM tests, the whole challenge of figuring out what true understanding even means, and that really fascinating connection between ToM and pragmatic communication.
It's a lot to take in, for sure,
Yeah.
but that's what makes it so interesting, right? I mean, we're essentially trying to understand the very nature of understanding. Yeah, exactly. And as we've been talking about, LLMs are giving us this really unique perspective on these questions. But before we, get too carried away with the possibilities, I'm really curious to hear what you think about the current state of all this research. Like, what are some of the big unanswered questions that researchers are still wrestling with?
Well, one of the most fundamental questions is, are these LLMs really capable of developing a genuine theory of mind? Or are they just becoming super sophisticated at mimicking, human-like behavior?
Right.
We talked about those classic ToM tests and how we need to move beyond just looking at, the outputs, the answers they give. But even with these more advanced ways of evaluating them, it's still incredibly difficult to say for sure, is an LLM really understanding these mental states, or is it just processing information in a way that happens to, line up with what we expect?
So it's like we're still trying to figure out, are they really speaking the language, or are they just really good at, kind of faking it?
Yeah, that's a good way to put it. And that actually leads to another really interesting question, which is, what would it even mean for an AI to have a theory of mind? Would it be the same as human ToM, or would it be something completely different? Because, let's face it, these LLMs, they're built on such different architectures than our brains. They learn and process information in totally different ways.
So even if we find really strong evidence that they're doing something that looks a lot like ToM, it might not be ToM as we know it. It could be something, totally new, something we haven't even thought of.
Exactly. And that's what I find so exciting about this whole area of research. It has the potential to not only teach us more about AI, but also to kind of challenge our own assumptions about, what intelligence even is. It's forcing us to ask these really basic questions like, What are the essential ingredients of theory of mind? What are the core computational mechanisms that make it possible for us to understand each other's minds?
And maybe by studying these LLMs, we can actually learn something new about those mechanisms,
Yeah.
in ourselves.
I think that's definitely a possibility, yeah. This research could really shed light on parts of human cognition that we haven't fully appreciated before.
Okay, so we've got these like huge questions about the nature of Tom and whether AI can really possess it. But what about the practical side of all this? Like, where do you see this field going in the next few years? What are the potential, real world applications of all this?
Well, I think one thing we're going to see is, much more progress in developing LLMs that can interact with humans in these really nuanced and intuitive ways. Imagine like AI assistants that can not only understand your commands, but also kind of anticipate your needs, adapt to how you're feeling, and even like engage in meaningful conversations.
So almost like a personal assistant that can actually read your mind.
Maybe not quite read your mind,
Yeah.
but definitely pick up on those subtle cues and, change their behavior accordingly. And I think we'll also see applications in, areas like education and healthcare. Like imagine AI tutors that can tailor their teaching methods to like how each student learns best, or AI companions that can offer, personalized support and social interaction for people who are maybe isolated or dealing with mental health challenges.
Those are some really, really interesting possibilities. But as with any, powerful technology, I guess there are also potential risks and ethical things we have to think about, right?
Oh, absolutely. As we develop these increasingly sophisticated systems, we really need to do it in a way that is thoughtful and responsible. We have to be aware of things like bias, privacy issues, and the potential for misuse.
So the future of AI in Tom it's exciting, but it's also like potentially a little bit daunting. It's a journey that requires not only scientific progress, but also a lot of, careful ethical consideration.
I completely agree. This is a field that's moving so fast, and it's really important that we have these open and honest conversations about, what these advancements could mean for all of us.
Well, I think we've definitely started some of those conversations today. So for our listener, we've really gone deep on the complexities of theory of mind. We've explored the challenges of trying to measure it in AI. And we've, gotten a glimpse of those really exciting possibilities that are still to come. We've seen how this research is really pushing the boundaries of what we thought we knew, not just about AI, but about ourselves as well.
It's been a fascinating journey, and I hope it's given you a sense of, wonder and maybe a few new questions to think about because as AI continues to evolve, this whole exploration of theory of mind, it's going to remain, a crucial and totally captivating frontier.
This has been the deep dive, and we'll catch you next time for another fascinating exploration of the world around us.